Alright, welcome back. It's the third lesson today, and we're going to keep on solving. This stuff is still the same as it's been the entire day, and it's going to continue to be focusing on finding that value of x that makes an equation true. Start with a skill check and make sure you pause and get that done quickly. Okay, let's check your work now. Combine like terms, 5x and 2x, they have identical variable parts, x to the first, x to the first. Combine the 4y and the negative 3y to get 1y, and 1 that's positive and negative 5 make a negative 4. Distribute the negative 2 to the positive k and the positive 9, you get negative 2k minus 18. Finally, negative 3 times positive 17 is negative 51, but negative 3 times negative 2 gets positive 6y. And our goal in this lesson is to solve equations that have variables on both sides. In other words, they have equivalent variable expressions, which means that they might look different, but they are worth the same amount of, or they have the same value, I should say. So, we'll take a look. Let's look at the equation 7n minus 5 is equal to 10n plus 3. Now, this is a little bit different because typically the n has only been on one side of the equation and it seems to be pretty easy to get alone. And so the idea here is you want, again, to get the n on one side of the equation. And you could use the subtraction property of equality or the addition property of equality to try to move these over. And so I'm going to use the subtraction property of equality. I'm typically going to make sure that my coefficients stay positive. So if I had to subtract either a 10 from 7 or a 7 from 10, I'm going to choose to take the 7 away from the 10 like this. I'm going to take the 7n and I'm going to subtract 7n from both sides of the equation, or in other words, from both expressions, 7n minus 5 and 10n plus 3. This will eliminate the 7n on the left expression and leave me with negative 5 on the left side, and 10n minus 7n gets me 3n plus 13. Again, pause the video if you need to. Hopefully you understood why I did that. The goal, of course, is to solve for n. Get that n by itself, so no coefficient is by it, and I have no sum, difference, or anything else next to the n. That being said, I want to get rid of the sum of 13, so I subtract 13. Use the inverse operation to get rid of that positive 13. And I have an equation I can definitely solve now using the division property of equality. You should get n is negative 6. And you could still check. You could always check to make sure your solution is true by plugging it into the top part of the equation. Now it's your turn to do some work of it on your own. Please pause the video. We'll check it back in a little bit. Your first step on this one is I subtracted 3n from both the left and the right side of the equation. 5 minus 3n is 2. n minus 2 equals 6. Add 2 to both sides. 6 plus 2 is 8, divided by 2. n is 4. 5 times 4 is 20, minus 2 is 18. 3 times 4 is 12, plus 6 is 18. It works. Subtract 8y from both sides. Add 17. Divided by 3. 8 times 7 is 56, plus 4 is 60. 11 times 7 is 77, minus 17 is also 60. Subtract m from both sides, just 1. And notice that this negative stays negative. It's still a negative 1 over here. Alright. Then I subtract 15 from both sides. Negative 1 minus 15 more is negative 16. Divided by positive 8, m is negative 2. And of course, it wouldn't be algebra if we didn't have some more word problems. How many students must go on the Spanish Club trip? The Spanish Club is arranging a trip to the Mexican restaurant in a nearby city. Those who must go share the $60 cost of the bus and the buffet costs $5 per person. How many students must sign up for this trip in order to limit the cost to $10 per student? In other words, I want the $60 plus $5 per student to be equal to $10 per student. If I use the verbal model, I want the cost per student times the number of students to be equal to the cost of buffet times the number of students plus the cost of the school bus. I want the cost per student to be 10 per student. The buffet is $5, the bus is 60, and the number of students is what I want to know. Combine by subtracting 5s from both sides to get an equivalent equation. 5s equals 60 divided by 5. S has to be 12, which means that 12 students need to go on the trip. Now I understand that I'm not here to help you with these, and I apologize. When I get back on Monday, I'll be sure to go over more of these word problems with you because I know they can be difficult, especially to write the equation. It takes a little bit of practice, and it does take some knowledge of English. You have to know how to read and speak English pretty well. All right, here's another example. This is the interesting part. There are some times where you try to solve an equation and you actually get something that doesn't make sense. So we're doing an equation that does not have a solution. What that means, there's no value of x that I could plug in to both places to make this equation true. Let's take a look why. Begin by just looking at the equation and then trying to figure out what to do next. In this case, distribute the 5 by multiplying. 5 times 2, 10x. 5 times 1, 5. Now watch what happens. I want to move the x's to one side of the equation. So I subtract 10x. I don't have a choice. They're both the same. So I just subtract 10x. And of course, they go to 0 on both sides, but this has an extra 5. Now I have this equation that says that 5 is equal to 0. Excuse my yawning there. That's not true. So we would say that there is no solution to this equation. There's nothing that you plug in for x to make 5 equal to 0. They're different numbers. It's not true. Because in an equation, the left expression has to be the same as the right expression. There's no exceptions. And even more strange is solving an equation where all numbers work. What that means is I could put in any number for x and it still would make sense. Here, let's see why. First, use the distributive property. 6x plus 2 is equal to 6x plus 2. And you could see that I have an identical, not even just equivalent. It's equivalent for sure, but it's identical. It looks exactly the same. So obviously, no matter what I put in for x, if I put in 1 or 6 or 9 or even a million, for any value of x, the statement 6x plus 2 is equal to 6x plus 2 is true. Like saying the sky is blue, it's always true. Okay, maybe not. But typically, there's something else that you could think of that's always true. All right, let's do some more practice. Pause the video. Make sure you get this down. Okay. First problem. Combine like terms. I decided to subtract 5x from both sides. It's worth noting that if you subtracted 7x from both sides, it would still work. You just have a negative 2x. Subtract 18. Oops, I think I forgot to write that as just x. It should be just x here. Let me fix that quick. There you go. Now, example 2 on this page is just like example 2 with the Spanish Club. We have a total budget of $300. Nope, I'm sorry, not a total budget. We just know a constant price of $300 for the bus, $8 per person, and I want it to be $20 per person at the end. So 300 plus 8 per person, we want to end up being $20 per person after we share that bus ride between all of us. I combine like terms by subtracting 8p from both sides, divided by 12. We need to get 25 people on this bus and tour guide to make this $25 per person. I'm sorry, $20 per person. Keep misspeaking here, I apologize. Example 3. Use the distributive property, 4 times negative 2, 4 times positive 3, negative 8 plus 12y equals 12y. Negative 8 equals 0 after I subtract 12y and 12y from both sides. And obviously this is not true. Does not make sense. So we would say that there is no solution for x. There's no value that makes this equation, I'm sorry, for y. There's no value of y that makes this equation true. Okay, let's get to work on your packet 3.3. Almost done today. Again, after this, you're going to have a quiz and make sure that you prepare by doing the review that Ms. Hyder will give you and making sure to check your answers.